Hello, and welcome to the Six Figure Developer podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I am John Calloway.
I'm Clayton Hunt. With us today is K. Scott Allen. Scott is a software developer, Pluralsight author, Microsoft Regional Director, and CTO of Medisolv. Welcome, Scott.
Hi, thanks for having me on.
So, Scott, why don't you give us a little introduction to yourself, maybe how you got started in the industry?
Sure, I got started because I was attracted to computers at a young age, like a lot of people in this industry, and like a lot of people my age, that started with some of the first home PCs. So I was very privileged and fortunate to have my parents bring home a Texas Instruments home computer one day when I was about 12 years old, and I started programming in TI Basic on that and decided that was what I wanted to do for the rest of my life, actually pretty early on, which was good. So I went to college for computer science and graduated and started working jobs with various larger companies. And since that time, I've decided I really like smaller companies better. So I've mostly been bouncing around with smaller companies and starting my own business, and it's all worked out so far anyway.
Excellent. So what are you working on these days?
These days I spend a lot of my time, well, I spend some of my time making videos for Pluralsight. That's worked out really well over the years. I also spend some time doing some independent consulting. I've kind of scaled that back. I really just have one client now, a company named Medisolv, where I'm also the chief technical officer, where we're doing a lot of microservice-based development with .NET Core. This company's actually been around for over 20 years, and we've always been on the Microsoft technology stack. And I've been working with that company on and off for 18 years, either as a full-time employee or as a contractor. And we've always been on the Microsoft stack, but these days everything is, we still have web forms applications that we keep running and then we add features to, but most of the new development is cloud native development, .NET Core, and like a microservice-based architecture. So most of my time over the last couple of years has been spent focusing on the cloud and designing resilient, scalable, performant systems.
Very cool. So I heard a lot of the new and exciting terms in there: the microservices, .NET Core, cloud native architectures. Do you want to go into a little bit of that information?
Oh, sure. We can go into any of those. I guess I could start with cloud native. I think that's one of those fancy terms that gets thrown around a lot. But to me, it really just means you build a system with the intention of deploying on platforms in the cloud. So you're not necessarily going to a provider like AWS or Azure and trying to carve out your own infrastructure and creating virtual machines. You're typically looking for a platform. So for example, I look a lot at app services in Azure, because app services is quite flexible. And basically, if you have anything that listens for an HTTP or an HTTPS connection, then app services can be your host. So you can develop software to place it into an app service and have a nice managed environment where you don't have to worry about patch levels for the operating system or patch levels for the web server, or you don't have to worry about some of the low-level configuration that you would need to manage in an infrastructure environment. And to me, that's cloud native. So picking platforms, like instead of, again, provisioning a VM and installing my own SQL server, I would rather use a platform-based database like Azure SQL or Cosmos DB or anything else where I can just say, give me a database, this is the size I want, and you manage all the little details. You don't need to tell me that you're rolling out new updates every 7 days. As long as the uptime is there, I don't really care. So to me, that's what cloud native is really doing, is targeting platforms and moving away from infrastructure a bit. And it can be serverless. I'm a fan of serverless. I do think it's overhyped sometimes, but I don't think you have to be serverless necessarily to be cloud native. And then microservices, to me, are just a way to say, I need to build a system that's relatively complex, and I would like to build that system not by creating one big monolithic team, because to me it's more about teams than the app. What I'd like to do is have a team of 5 developers here and a team of 5 developers over there, and have them coordinate what they're building through the usage of APIs or messages or what have you. But they're able to pick their own schedules and their own release cadences and their own data persistence, and really be isolated in how they architect and design everything, and not be coupled together so that we have to wait for all these people to come together to produce some new release for QA or some new release for the customer or production. And to me, that's been working out pretty well over the last couple of years. I've seen both the good and bad of microservices. So the good point is everyone's working independently and they're rolling things out whenever they want. And then there's the downside, which sometimes that type of architecture can be a little bit harder to see what is happening and what is going on. But that development time, like what really happens when I call that service? Now I have to go over there and figure out what's happening because something in the system's not producing the right result. So it's a little more difficult at development time, and also at runtime, you'll learn pretty quickly if things go south for your customers and your customers are seeing errors. There's going to be a lot of pressure on the teams to come up with an answer right away. So if you don't have your logging and events and alerts set up properly, there's going to be a lot of scrambling and people trying to diagnose problems by running around all over the place trying to put things together. But like with everything in software, we try to learn as we go along and get better. So I think the downside to microservices, I think it's easy to scare people about the downsides, but I think once you actually get into production and see the benefits, you'll realize you can work with those downsides. You can make them work for you.
So having worked with
Having
worked
topic,
with,
but I don't remember what it was.
Yeah.
Go ahead.
So having worked with Medisolv for a number of years, and I would imagine transitioning through technologies, or at least versions of Microsoft technologies, going from, I think you mentioned web forms and moving into .NET Core, I presume, and into more cloud native architectures. Has it been tough, or what are the ideas to keep in mind when trying to keep an existing system or suite of applications up to speed and up to the latest and greatest, or at least in some sort of maintainable state?
Yeah, it is definitely a challenge. And I think it's an argument for building smaller pieces, like with a microservice-based approach, because I do look at one of the web forms applications, which is a complete monolith that was started on 20 years ago. And quite frankly, it'll probably never be rewritten. We have to add features once in a while, but I look at that technology stack, and it's based on ASP.NET, and yes, the majority of the application is web forms, but there's ways to wedge other technologies into ASP.NET so that you can take advantage of different amounts of flexibility. So for example, you could add in HTTP-based web services to that application. It doesn't have anything to do with web forms. You could add in ASP.NET, the classic framework that runs on the full .NET framework for new features. And you can throw in Angular and React and Vue just because they're client-based and web-based, and web forms doesn't really care, what it's serving up to the client. So that's something to keep in mind. But definitely, moving forward, it's nice to have everything on .NET Core, which has been a really pleasant platform to move to. I think the flexibility and performance of ASP.NET Core has just breathed new life into the .NET framework for me. It's really come around 180 degrees over the last 5 years with .NET Core.
With that, yeah. So we're trying to pass notes back and forth.
Yeah.
Sorry.
But we'll cut some of that out. So with that, do you have anything already running in .NET Core 3.0? I know at the time of this recording, it's only been in full GA and for a couple of weeks now.
Yes, there is. In fact, just because I did take liberal advantage of the fact that there was a go live license before GA, and although there are a couple bumps when you adopt something a little bit too early, with .NET Core 3, it was mostly smooth transitioning from the betas and the release candidates into production. And there were some specific things I wanted to get out of .NET Core 3, like the new hosted services features and things like that. And I wanted to start work on some of those things without waiting another 2 or 3 months for GA to happen. And it's all worked out.
Have you done anything with the .NET Core 3 workers?
Yes, I mean I think there's a lot of stuff that I see that we're building for the cloud that just needs to be a worker. So you can use, and so the great thing about .NET Core 3 is they took this idea of a host, which used to be a web host, right? Because everything we wrote with .NET Core was either going to be a simple console application or it was actually going to be something that was a web host, right? It was going to listen for HTTP messages ultimately. And they took that idea and they genericized it a little bit to say, let's just make this process a host. You know, it could be a host for some service that is running that could actually be like a real Windows service. If you want to install it on Windows or a Linux-based service. But it's just going to be something that listens in the background. It's not necessarily waiting for messages. But a service like that can still benefit from all of the infrastructure that the .NET Core web host was providing for web applications. So infrastructure like application configuration. Where do I get my configuration values from? Is it from JSON files or environment variables or command line arguments or all three? Infrastructure like logging. What's my logging level? What are the different types of logging syncs that I have installed into the application? And also the big one to me is also the service provider. So to have an inversion of control container available in a simple process that I can spin up and have a worker process running, being able to use dependency injection in that without writing all that stuff myself, I think is a big benefit. So to me, that was a big move forward for .NET Core 3. It was the realization that, look, people are going to be writing a lot of things that run in the cloud or run as a service, and they're not necessarily web servers. So they're going to be things that are listening for messages that are queued in a message queue, or they're monitoring blob storage, or they're just sitting there waiting maybe with a different type of endpoint other than HTTP.
Recently, John and I have both been working on independent projects to modernize old applications. The one that I'm working on is actually classic ASP, and I'm upgrading it to .NET Core 3. Where would you start with something like that? I know you said that you have your web form apps, and because they were built as monoliths, it's likely that they won't get upgraded. But if you did get the go-ahead or the company wanted to push for that, what would you start with?
Yeah, I mean, I would probably, depending on the application, I guess, thinking about like the applications I'm experienced with, I would try to find a way to carve things up in that application. So if I could take just like the admin chunk of that application and run it as a separate website, to do that somehow and just rewrite that admin section with a new technology like .NET Core and Razor Pages or .NET Core and Web API or whatever it has to be. And obviously I think anything that's building APIs is going to be a little bit easier to rewrite than anything that's dealing with UI technologies. So web forms is tricky because web forms was such a different programming model from what the entire rest of the universe was doing for the web. So when developers sit down and look at how to implement something in web forms, how to implement something with pretty much any other framework, there can be a bit of a rough transition there. But trying to get into an environment perhaps where you can run side by side, I think is always advantageous, and that can be a little bit difficult these days, and it can be a little bit difficult with .NET Core 3, unfortunately, because it doesn't support the full .NET framework any longer. But yeah, I usually try to look for scenes where you can tear the application apart and maybe pull out some pieces that can run independently. That's usually my first line of attack.
So it looks like you've been blogging a lot about Blazor lately, which is probably my favorite thing for .NET Core 3. Have you been doing anything for that production-wise, or would you consider that at this stage?
Yeah, definitely Blazor is something. I've written a couple things that are critical of Blazor, and I've gotten some heat for that, but I just want to say everything I write that's critical of Blazor is because I really want Blazor to succeed. So I'd like to provide constructive feedback that ultimately will make it a better product, because I really want Blazor to succeed. I kind of got so frustrated with UI development a couple years ago that I walked away from it, and I said I never want to see another Webpack configuration file or npm install anything again. And I've mostly avoided that world, but it's hard to avoid these days. So, so that's the first part of my answer. Yes, I'm excited by Blazor. I want to see it succeed, and I think it's a very interesting technology. That being said, I think I do have still some concerns about Blazor putting it into customer-facing production applications. Right now, we've got a couple things going on with the Blazor where we're building things that are going to be used internally inside the company, or internally for like the QA team to build test data, that sort of thing. And so far, so good. I mean, all the feedback is good, been good, and everything is stable. And the little bit that I've used it, I find it to be an amazing technology. I find some things about Blazor a little bit frustrating. I wish there was a way to there's always ways to keep C# code out of the UI, out of .razor files, right? And for anyone that's done any UI development, like with Silverlight, we know that view models are your friend, and try to keep as much logic inside of a view model so it's not so tied to the UI. But that Blazor programming environment still bothers me a little bit. Having code blocks inside of Razor, the IntelliSense just isn't the same. The code formatting experience just doesn't seem to be the same. The refactoring just doesn't seem to be the same as if I were able to write a class and put it in a .cs file. I hope we can get to that model someday, even if it's for the client-side stuff that gets compiled into WASM. That would be awesome. The development time experience to me still also is a little bit wonky. So I have the Blazor app up and running in my browser, and I'm making some changes in my code, be it in a Razor file or in the ASP.NET application project, whatever I'm doing, that I come back to the browser and the connection is broken and all these things have gone wrong and I have to hit a hard refresh on the browser to bring the thing back to life. I think there's just some edges like that could be a lot smoother to make the Blazor development experience a lot smoother. But again, that being said, the ability to handle, I can handle click event with C# code in the browser can be pretty powerful and pretty amazing.
Yeah. Some of the things you brought up are big things for me too. I kind of always fall back to web forms and the MVP pattern, which is my favorite way to do web forms. And I kind of want to do the same thing with Blazor and move the code out into a kind of a presenter. And you can have a code behind, but it's not the most straightforward thing to do.
Right.
So I definitely agree with that. And the development experience is subpar for most front-end libraries at this point. If you have an Angular or React application or Vue, you make a change, hit save, and then it automatically updates in the browser, which would be super nice. I feel on that aspect, I feel like I'm kind of back in web forms where I'm having to like stop, start the application, go back to the page I was at. But I'm with you on staring at Webpack configurations and stuff. I don't think I can take any more JavaScript right now.
Yeah, I mean, the one nice thing I can say about Blazor is that it doesn't break every week with an update, so that's nice. And again, I'm only critical of it because it's early, and I know there's room for an improvement, and I think it could be great. So hopefully, by the time Blazor version 3 comes around, there'll be nothing but gushing good news about it.
Yeah, it's definitely come a long way in a relatively short amount of time. Are there specific concerns that have already been addressed, or are there specific concerns that you have that have yet to be addressed that you think are kind of deal breakers at this point?
Yeah, one of my concerns was just scalability for like a large public-facing website, which actually isn't a huge concern for me because I'm not working on Amazon.com or necessarily a huge public-facing website. But I still wonder what people are going to do in those situations where you have all these socket connections back to a specific server. I just don't know how far the server-side model can go. I know that the team has been putting together, I think, some white papers on to publicly show everyone what the state of scalability is for server-side Blazor. So I'm interested to see how those come out.
So Clayton and I, at least, have spent a lot of time in JavaScript over the last few years, specifically. We've worked in Knockout and Angular JS and Angular and React. And I think at some point or another, we've both probably wanted to abandon JavaScript as well. Moving into like a cloud native mindset and microservices and little .NET applications running everywhere. Do you find that you have the ability to make the types of applications that you need in that type of architecture, or what types of applications are you doing that don't require the single page application frameworks?
Oh, yeah, there's definitely applications. I mean, most customer-facing applications that have a UI these days are going to need some amount of client-side development, and a lot of them are probably going to need to be spas. It's just that I don't want to be the person to work on them. But that being said, I see a lot of applications being built that are still primarily server-rendered HTML with a little bit of something like Angular sprinkled in here and there, or perhaps even something like Telerik controls sprinkled in here and there to provide an interactive grid. So I'm thinking about applications, particularly applications that are presenting information that a user requires and are not necessarily that interactive. I'm going to show you some financial results from last quarter, and here's what you get to see, and maybe you can do a little bit of sorting and filtering, but it's not going to be workflow type application where you have to click a bunch of things and fill in information and advance through a wizard, things like that. But the type of application sometimes that I've been building, the most productive way to build those applications is still to use server-rendered HTML. It's the fastest way to crank that application out and have it be of the highest quality and tested and scalable and all those good things that we look for. It's not going to be the most interactive, but it's also not required.
Yeah, we work on a lot of line of business applications as well. So, we're accustomed to a lot of server-side processing and manipulation of data and moving of files and those types of things that you're right. They don't require a lot of the bells and whistles that the Reacts and Angulars and Vues can lend to an application. They're nice little touches here and there, and certainly provide a nice user experience. But for the most part, I'm these days I'm more interested in processing power and speed of applications and handling of events and handling of concurrent connections and those types of things.
Yeah, most of my world these days, a lot of it is spent on back-end processing and moving data around beyond. So trying to amalgamate data from different data sources and squish it together and save it somewhere so you can process it and save it somewhere so that is might be useful for an application or might be useful for analytical tools and that might be two different places, depending on what you're building.
What types of problems are you solving for Medisolv with the intensive data work there?
So a little bit about Medisolv. They basically produce applications that calculate quality indicators in the healthcare industry. So a quality indicator basically tells you, a physician, or you, the hospital, if you did a good job with a patient or not. And the way it has to do that is by looking at all the information that you have about a patient and try to run some algorithm. So I can give you a very simple example. Like if I show up at the hospital with chest pain, a best practice for the hospital, at least used to be, that I receive an aspirin within 60 minutes of my arrival, because an aspirin will thin the blood, and if my chest pain is because of a pending heart attack, that might help prevent that heart attack. So you can look at all the data for a hospital, everything they record about a patient and what they were given and what their initial diagnosis one is, and you could say, oh, you had 100 patients arrive with chest pain, 95 of them you gave an aspirin within 60 minutes, so you get a 95% seal of approval, and you can compare that to other hospitals. Now, there is actually no quality measure that is that simple. These days, they're all a lot more complicated with that, but that's just like a simple example of the things we're trying to do. But in order to pull that off, we have to pull information about patients, and it's just a lot of data. I mean, but you would be amazed how much data about you is recorded when you enter a facility, or a doctor's office, or a hospital. So there's your diagnoses, and there's your lab test, and those lab tests have results, and your prescriptions, and your procedures, and it just goes on and on. So the ability to take data from disparate systems, so every hospital system has slightly different EHR and might have data in slightly different format, and to be able to move that around efficiently is actually proven to be a bit of a challenge in the cloud at times, because even though the cloud is advertised as this big, scalable, high performance system where you just pay for what you need, the truth is sometimes you have to pay a lot for what you need. So trying to find ways to move large amounts of data without paying more than what your customer is willing to give you has been a bit of a challenge, and sometimes that's just finding the right technology. So let me give you an example. I can buy a nice beefy 8-core 32 gigabyte or 64 gigabyte of memory server and run it in my server closet and put SQL Server on there, and I can, with that kind of server, I can probably handle databases of 250 gigabytes pretty decently, right? And so on-prem, I made one upfront capital expenditure, and yes, I'll pay people to maintain it and apply patches and make sure there's backups and some amount of redundancy, I guess. So it's not, just that one-time expenditure. But now let's move that into the cloud, right? How do I take that 250 gigabyte database and move it into the cloud, where I have all these additional features like the automatic backups, and it's going to be highly resilient now. It's guaranteed to have a certain uptime. It's got, it's inside of a building that's physically secure. It has generators all around it. There's a reason that Azure SQL is relatively expensive, right? You get a lot for what you pay for. But at the same time, if all you were doing is using that database to just slam data together, right? You're just looking at tables and doing joins and just trying to produce results. You're not necessarily doing actual transactions where you're saving incoming, account orders or things like that. Just to slam data together, Azure SQL is very expensive for that type of operation, because again, with Azure SQL, you're paying for the redundancy and the high availability.
Mm-hmm.
There's other options that can be better for that. So, I've gone on this long description because what I wanted to point out was that for some operations we do, it turns out something like Apache Spark is a much better solution, because Apache Spark is basically a way to say, give me this much computing power. I want, this many cores, this many servers, this much memory, and now I'm just going to use that cluster to plow through a few gigabytes of data, produce some output file, and then I can cache that for a few days, and then now that kind of approach is going to be a lot cheaper than trying to provision a SQL server for that particular solution. So it's all about learning what's available inside of Azure and trying to figure out what you really need and what you can pay for, and how you can do things more efficiently and for less money.
Okay. So right
Hopefully
tool
that's
for the right
making
job.
some sense. Yeah, as always. To me, software development is always about finding a solution that gives you the problems that you're willing to live with, right? So, because finding solutions in software development, there's always trade-offs to make, right? You can find something that is fast, but it's going to cost more. You can find something that's cheap, but you have to live with the performance. So just pick the solution that gives you the problems you're willing to live with, and you'll be happy.
All right. One of the things that we ask all of our guests is to provide us with some advice that they might give to new and aspiring developers or developers who are kind of ready to reinitiate and jumpstart their career. What kind of advice would you give for those types of individuals?
I usually tell those types of individuals to remember that you are in a marathon and not a sprint. So, don't be disappointed if you've worked really hard on something for the last month or even 3 months and it doesn't seem to be getting any results or you don't seem to be getting anywhere, because really you're in a marathon. So if you can keep up a level of consistency and passion that is measured in years instead of weeks or months, you will definitely get somewhere, because you'll be producing better results than a lot of other people that are either not as passionate or not as interested, or they're doing too much in a short period of time and they're just getting burnt out and frustrated and walking away from it. So just maintain that slow, steady pace and look at the long game, and you'll be fine. You'll come out on top.
All right, cool. Thank you. What kind of resources might you suggest to somebody for .NET Core, Cloud Native, microservices?
Well, there's always a ton of stuff on Pluralsight, but that would be plugging my own stuff. So
we're perfectly fine with that.
Good. Pluralsight has a ton of stuff on .NET Core. Yeah. Microsoft documentation, honestly, has come a long way over the years, and if you want to do something for free and you enjoy reading, honestly, reading through some of the Microsoft documentation is not that bad these days. There's some pretty good articles on architecture, pretty good articles on design, and the .NET Core documentation is not like the documentation of old where it's always just, here's the method named do work, and what does it do? It does work. There's actually some pretty good articles that go into how to build software and how to put things together and cover some best practices. So it's not bad.
All right. What about social media, maybe Twitter? What kind of links, if somebody wanted to follow you or read up some more of the stuff that you've been saying?
Sure. I mean, I try to regularly post on my blog, odecode.com. That's a good example of something that I've looked at as a marathon and not a sprint. So I've been plugging away on that blog since 2003, and it's provided some enormous benefits to me over the years and given me a lot of opportunities that I never thought I would have. So I just keep at it. So odecode.com is my blog. Odecode is my Twitter handle, where I'll tweet out links to things I've written or retweet things that I've appeared in or videos that pop up. So.
All right. And last but not least, do you have any upcoming speaking engagements?
I kind of took this year off. I think the next public speaking I do is actually, I do have an appearance at a Chicago user group in December. Unfortunately, I don't remember the name of the user group, but it's a .NET user group in Chicago. I'm sure there can't be more than, 6 of them. But then the next conference I do right now, I think, is going to be in DC London, which is in late January of 2020.
Very nice. Well, thanks, Scott. Really appreciate you taking the time to speak with us today.
Sure. Thank you for having me. I hope everyone enjoyed this.
That was K. Scott Allen. Scott is a software developer, Pluralsight author, Microsoft Regional Director, and CTO of Medisolv.
If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
And I'm Clayton Hunt.